What we're looking at today is how to combine functions. So adding functions. It's quick to draw functions when it's a transformation of a basic shape, but what do you do when it's not? So we're going to take some shapes we know, work with these, and see how to add functions graphically. So here's the idea. We have two functions, y equals 3, that's the black line, y equals x, that's the blue line. And we're going to add them together. What we mean by that, I want you to imagine this lovely straight line that I'm drawing. And we're going to look at where this lovely straight line crosses the first function and crosses the second function. The y value at the first one is 3. The y value at the second one is -5. When you add 3 and -5, you get -2. So we get a new point that's the sum of the other two y values, and we're staying at -5. Let's repeat that process. Let's take another lovely straight line and see where it crosses the two graphs. Crosses the first one at 3 and the second one at -3. When you add those together, you get 0. Let's repeat the process. Where does this cross the two lines? Crosses the first one at a y value of 3, crosses the second one at a y value of -1. 3 plus -1 is 2. Let's do it again, and we're just going to keep doing this until we're 100% sure that we know what the graph looks like. This one crosses at 3, this one crosses at 1, 3 plus 1 is 4. I'm hoping you're starting to get an idea of what the shape of the final graph looks like. I'll just do one more. There's our straight line, crosses both of them at 3. That's interesting. So that'll give us a point at 6, and we have this lovely straight line that goes through these points. Yours is going to look much better than mine. Okay, what have we learned? What's the equation of our new function? It's a y equals x graph, and it's shifted up. That should be at 3, forgive me. Shifted up 3. So our new function would be x plus 3. There's another way to get that. This is one function. This is the second function. We're adding them together. There's our graph. X plus 3 or 3 plus x. Same thing. X-intercepts of the new graph. Let's see what we've got. Where does it cross the x-axis? At -3. All right, could we have predicted that just by looking at the graphs of the original functions? Where would you get yourself an x-intercept? Anywhere that the two y values are opposites. So we had a y value of +3 and a y value of -3, and they would eliminate to get a y value of 0. So you can predict your x-intercepts ahead of time. Stationary points, these are useful. Let's talk about these. Are there any points on the new graph that were also on the old graph? So we're looking at this beautiful red line. Does it cross either of the original graphs? And it does right here. So think about, why did this point not move? What's happening when x equals 0? What's the other y value? The other y value is 0. When you add 0 to something, nothing happens. So stationary points are formed when one of the original functions has a y value of 0, because then the other one doesn't move. That's going to help us draw graphs quicker. So keep that point in mind. So 0, 3 was a stationary point. Which of the two original functions is the dominant function? Now, when you think of dominant functions, think of dominant genes. So do you look more like your father or your mother? Which genes dominate? So if we look at the red graph as the child of the other two graphs, which one does it look more like? It looks more like the y equals x graph. And can we think about why y equals x would dominate y equals 3? One way to think of it, the exponent on x is higher here than it is there. So an x dominates a 3, and x squared would dominate an x. Another way to think of it, it's really got to do with larger y values. So you can imagine a tug of war between the two functions, and the one that wins the tug of war is the bigger one. Dominant functions are going to be a very quick way of drawing graphs, so keep it in mind. It's got to do with the larger the y value, the more dominant the function. So these y values, bigger in scale than those ones, so it draws the graph closer to the bigger y values. And when we talk about big, we mean in size. I know that -6 is smaller than 3, but if we think of the absolute value of -6, then that's a bigger value than 3. So we're looking at the size of the number, not whether it's negative or positive. All right, let's determine the domain. So domain of the original function f of x equals 3 is all the reals. Domain of g of x is all the reals, and therefore the domain of h of x is all the reals. If there had been a restriction on any of these, let's say f of x didn't exist for part of the graph. If that didn't exist, then when you tried to add g of x to it, you wouldn't end up with anything. So the domain of h of x, you have to exist on both functions if you're going to exist on the final answer. All right, how does this work? Let's add these two graphically. So again, draw yourself some lines. Ooh, wait a minute. Did we talk about stationary points? Anywhere one of the graphs is equal to 0, the other one doesn't move. Beautiful. So we've got 2 points without doing any work. So how did that work again? The y value is 0, add 0 to -4, and you stay at -4. Add 0 to -1, you stay at -1. Okay, then we'll start drawing some lines in here. So I'm just going to put some lines in. I'm going to put them at fairly key points, so anywhere we shift direction, that'll be important. This one starts shifting direction there, so we'll put that in. These ones are pretty constant for a while, and maybe we'll put one more here. Okay, so we're comparing y values. Y value on that graph is 2. On that graph is -4. 2 plus -4 is -2. And the x value isn't changing. We're saying at this x value, add the value for f of x and add the value for g of x. At -1, we have a y value of 4, and we have a y value of -4. That gives us a lovely x-intercept. At 0, y value of -4, y value of 3. That gives us a y value of -1. So this is going to be a strange looking graph. Very predictable up here because both shapes are quite consistent, and then we're coming down. All right, what happens here? Y value of 1, y value of -2. All right, looks like the graph is coming along and doing this. And what happens at the end? Y value of 2, y value of -3. That gives us another y value of -1. So again, all we did, picked a collection of points, calculated the y values, added them together. And that's how we graph the new function. Useful is to find stationary points. Look for any places where either of the originals is an x-intercept, and then the other point does not move. Now, let's get into the dominant function. We have two functions. Y equals f of x, that's the green straight line. G of x equals 1 over x, that's the blue line. And this is where the idea of a dominant function is going to come into play. I hope I can get into here. Okay, so we're going to take this line and we're going to move it along the graph. I'm going to start here because this is where the two graphs cross. At this point, both y values are 1, so we'd have a new point at 2. I don't think my pen works on here, but we can live with it. Actually, I might be able to draw a point. Ah, there's our point. Then we're going to keep this moving. Whoops. Okay, that wasn't actually very useful. Okay, we're going to keep this moving Along this line, we have a y value of 2 and a y value of 1/2. We'd be up at 2.5. So we had a point at 2 and a point at 2.5. Now, let's think about it. As we move along this line, which of the two graphs dominates? The green or the blue? And I hope you're going to tell me the green dominates because the y values are bigger. So our graph is going to end up being much closer to this line than it is to this one. The other thing you might want to think about is, are we above that line or are we below it? So can you see that we're adding positive values? When you add positive values, you're going to end up above. So let me draw a very rough sketch of what's going on. We set it 1. When we were at 1, we said the two values are 1 and 1, so we'll get a new point at 2. And when we're at 2, we added 2.5. So at 2, we're at 2.5. And then we just stay slightly above this line. So our graph just stays slightly above the line. Looks a little bit like that. So it's running along the y equals x line. Stays above it, gets a little bit closer. Now what happens on the other side of this point? Which graph is dominating now? Which one has the bigger y values? It's the blue one. So now the blue graph is dominating, and we're adding positive y values. All these green values are positive, so we're going to be slightly above the blue line. So the graph is going to end up coming back here and staying slightly above the blue line. What happens at 0? At 0, we have a y value of 0 on the green line, but no y value on the blue line. That means we have an asymptote. And that makes sense that our graph is approaching the asymptote. Okay, can we get what's going on this side? Let's start at this point because it's nice and easy. At -1, both y values are -1. So at -1, we'll have a point at -2. On this left-hand side, which graph has the larger values? And again, we're talking about the size of them, not whether they're negative or positive. So the green values are bigger in size than the blue ones. So the green graph dominates. We're adding negatives, so we're going to be below this line. We're going to be more negative than we were before. So if we imagine this dotted line as being the original y equals x, we're just going to stay below that line. You can check a couple of points if you want. Let's see, at -4, we'd have a y value of -4 on the blue and -1/4. So at -4, we should end up at -4 1/4. That's where that's coming from. On the other side, which graph dominates? The blue points are larger in size than the green ones, so the blue graph's going to dominate. We're going to look more like the blue graph on this side. And we're adding negatives, so we stay below the line. So it's going to look something like that. Okay, it's pretty rough. Let's show you what it really looks like. There we go. So there was the point at 2, stayed above the green line, but we're very close to the green line. On this side, it was the blue graph that dominated. We stayed just above the blue graph. On the other side, at -1, we started at -2. At this side, it's the green graph that dominates. We stay close to the green graph. On the other side, it's the blue graph that dominates, so we stay close to the blue graph. And that's when you start looking at dominant functions. And again, why did they dominate? Because they're larger in size. Imagine a tug of war between these guys, and who's going to win? Okay, if you can master this skill, it will give you the ability to draw graphs very quickly when they are not basic transformations. Yes, it's going to take you a little bit of time to get comfortable with it, so make sure you do all the questions, take your time. If you need to put something down to see what you're doing, a piece of spaghetti works really well. You can move that along. You could use a pipe cleaner, just anything that gives you an idea of where your points are. All right, Get lots of practice and get good at this.